Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments, where tonight we'll take a look at teaching and learning mathematics with TI-Nspire CAS technology. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first TQ Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is McHugh, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to my students. I'm very happy to introduce our panelist tonight, Tom Riordan. Tom taught at Fitch High School in Austintown, Ohio for 35 years. He has served as an adjunct professor at Youngstown State University for the past 34 years. And as a TQ natural instructor, Tom has worked on the development of some very important TI products, TI SmartView emulator software, TI-Nspire CAS, and the TI-Nspire Navigator system. Currently, Tom works for TI in product strategy and development. He also does professional development nationally and internationally. Thanks so much for being with us, Tom.
Good to be here, Mike.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also be using the chat window to send messages. Once we move to the software, the right section of your screen will be replaced with a green floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available, if you'd like to follow along with your handheld or software, and we truly hope you will, we recommend doing this with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Tom is going to discuss our agenda and expected outcomes.
Tonight we're going to look at what is CAS technology and how does that mean, what does that mean about dynamic algebra, how to teach with CAS technology in grades 7 through 12 and beyond, some free online resources, and I also want to talk about an international CAS conference that will be held in Cleveland this July.
And then the expected outcomes, Tom?
So explore how dynamic algebra can be used to help students in grades 7 through 12 investigate algebraic patterns and relationships. Learn how teachers across the United States and internationally use TI-Nspire CAS technology in their classrooms to explore those mathematical relationships and to deepen conceptual understanding for students at all levels. Finally, to stay in touch with social media and upcoming events.
Thanks, Tom. And I think we're already seeing a lot of that international come into our field of view because we have a lot of people on tonight, it looks like, from all over the world. So that's really exciting. Thanks so much for being here. Tom, it's all yours.
Okay, thank you. Mike, can you see my desktop okay?
Yep, looks good, Tom.
Okay. All right, so good evening. Normally I'm in Youngstown, Ohio, which is very chilly, but now I'm in less chilly Dallas, Texas, just for tonight. And thought you might enjoy this cartoon to start us off. You might have to be as old as me to appreciate that. And I found this quote, "I don't know why I should have to learn algebra. I'm never likely to go there." Not sure who that is, but found it amusing. So tonight we're going to talk about what is CAS, and I saw some of you people on here are CAS, what I call CAS experts, and CAS people who have been around for a while, and there's probably several of you that are new to it. So we'll start with the new ones and try to keep everybody involved. CAS stands for Computer Algebra System. And this is computer software that will pretty much do everything that we teach from grade K through grade 12 in calculus, integral, and differential calculus and beyond. But it does it symbolically, not just numerically, meaning it does it in terms of variables, not just in terms of numbers. Other CASs include MAPLE. Some of you may have heard MAPLE. I know at Youngstown State University, MAPLE is the CAS of choice. Mathematica is considered the Cadillac of them. Wolfram Alpha, I'm sure you've seen that online, and Derive, and there are many others. Derive is the CAS that is on the TI-Nspire CAS. It's also the CAS that is on the 89, the 92, and for those of you who remember, the Voyage 200. Uses of CAS, I think originally they were for calculations that you really couldn't do by hand, or it's too difficult to do by hand or wouldn't want to do by hand. Example, solving a 50 by 50 system of equations, I'm not sure you would want to try that by hand or even with a graphing calculator. Verify the distance from a point to a line formula, things like that that would really be kind of sticky to try to do by hand. But other uses of CAS would be as an assistant to learning and discovering mathematics from pre-algebra, algebra, geometry, trig, pre-calculus, calculus, and beyond, grades 7 through 12. And that's what we're going to focus on this aspect tonight. So the first thing I'd like to do is using CAS to help students discover algebraic properties and to understand them. So let me change my window a little bit here. And bring up, and let me show you this in full screen first. This is a worksheet, or as many of you know, I like to prefer to call them GIFs. Worksheet just sounds so awful. This would be a gift I would give my students. And this is a CAS investigation of patterns for exponents on variables. This would be a way to use CAS to help my students discover, investigate, explore the properties of exponents. So what you would do is the students would be given this sheet of paper and their CAS and say, type this in there, write your answer here. And they would work at their own pace. It would work individually. And so I'm going to go ahead and show you how that would work. So here is the CAS calculator, and with the CAS screen right here. This is the gift or worksheet next to it. And it says to type in x times x. So I'll go over on my calculator and type x times x. A little bit, x times x, and then I would write x squared right here. That was my answer. And then I'll go to x plus x. Now this might be done in an Algebra 1. This might be done in a pre-algebra, 7th or 8th grade classroom. That would be depending upon your school's curriculum. So I'd write 2x here, and then x squared times x. And I'm using the emulator software, so this could be done on computer software. It could be done on a handheld calculator. So I write in x cubed, and then x squared plus x, and so on. Now you'll notice on this one, there might be some students that didn't do anything, but if they're new students, they're not going to say it didn't do anything. They just figure that's the answer. So what I'm trying to do is take on those types of issues right away before students develop some bad habits. So instead of just go ahead and continue to do that, I had done this just before we started. And so here's some of the other answers, x cubed times x squared, x cubed plus x squared. And so that the students could see right away, hopefully, what the rules for multiplication are, what are the rules for adding, and when can you add them, when can't you multiply, and so on. And they'll get down to this screen, part of the screen here, and it says in number 13, look at the exercises and the answers. Describe in words below what patterns seem to be true. So you're asking the students to see to observe things, but then also to put them into words. They may need to work in groups to do that, or in pairs. That would be up to you. I would encourage that so that they're more apt to talk and then be able to write something that makes kind of sense. Okay, so then we'll go on to the next one. So here, after it says that, it says using those patterns you noticed, in the first column, write what you think your answer is, then type this in and write down what the CAS says it is, And if they agree, put a smile face, and if not, put an X. But what happens is, if they get it right, that, of course, reinforces it. If they get it wrong, they have a chance to understand why immediately. It's immediate feedback. It's like having a teacher sitting next to you. And so they would go ahead and do number 15, x to the fourth plus x to the fourth, and hopefully write 2x to the fourth, and so on. And I can't remember if I have this on. So on the next page, this would be where they could type those answers in. And then after they've tried that, here's an optional part right here. And again, this would be depending upon the level of your students. But notice I'm asking them already to maybe generalize what's true and so on. So they would type what they think the answer is. Write in what they think the answer is. Type this into the computer algebra system, write that answer, and see if they agree. And so I think I already did this one on this page. Yes, I did. So you can see that this computer algebra system is able to generalize also. And you'll notice in number 24, it says, look at the answers to 22 and 23. How are they similar and how are they different? And some kids will say, well, they have a 2, an X, and A in them, but it just depends upon where they are, and have them start to discuss, why the A is in the exponent here, why the 2 is not in the exponent here, and so on. So again, you're asking the students to kind of create their own properties or rules, but hopefully correctly, okay? And usually when they do them correctly, they have ownership in them, they remember them longer, they seem to make sense. So then we'll go on to a little bit more complicated more examples. Now we have coefficients in front of the x's instead of just x and x squared and x cubed and so on, and ask them to type those in to the calculator and get the results. So I have already done a few of them. I'm sure that's not a surprise for your answers here. They would write them down and, again, start to look at the patterns, and they can start talking about that you sometimes multiply the coefficients, sometimes you add them, sometimes you don't. Okay, it just depends upon that, and they start to hopefully make the correct rules and understanding them. So now we're going to get to the assignment. Okay, you might call it homework. I prefer to call it opportunities to learn, OTLs. So it says here, for each of the following, simplify without using the CAS. Then type your question in and see what you get for CAS and see if you got it right or not. Now, the reason I like this is that if a student had x squared times x cubed and wrote the wrong answer here, then if there was x to the third times x to the fourth later on, probably going to miss it. But if I tell him or her right away, you got it right or you got it wrong, if you got it wrong, I have a pretty good idea they're hopefully going to learn from their mistakes. If they had done this the traditional way, missed this problem, and miss every other one like it, they come to class the next day thinking they know it, and they don't, and they're mad for many reasons. They're mad at you, they're mad at algebra, they're mad at variables, whatever. So the CAS helps them get immediate feedback right away. It's like having a teacher sit next to them, but the good part is the teacher, it's not a personal thing, okay? It's not a personal thing at all, and they're not embarrassed. All right, so I'm going to go ahead and minimize this right here and go back here, make this a little bit larger. Make this computer document preview. And go on to the next page. So by doing things like this, and this is just one example, and I know I went quickly, but hopefully you can see the impact, the big picture on this. But what happens is students create their own learning and hopefully correct learning. It is self-paced, and actually I've seen that students understand things faster, and you go faster than you traditionally would. You can address those common errors and address them head-on and hopefully eliminate them before they become bad habits. And notice that I combine more concepts together, in which actually lessens confusion. Because if you teach all multiplication at one time and you ask them to keep doing multiplication, they're usually pretty good at that because they don't have to make a choice as do I add or multiply or whatever. And so they're used to now starting to put the things together instead of saying, okay, this is adding and this is multiplying, and now let's put them together. Let's just teach them together head on. And it's with things like that that make CAS, I think, better, deeper, and faster in a good way. So when doing the homework or the opportunities to learn, it's like having a teacher sitting next to you, but again, like I said, without the embarrassment. Now, I understand that some of you might be saying, what if the students just use the CAS to, type in the answers? There's still no way around that, okay? I had thought about asking TI maybe to put a little shock treatment in there when that happens, but they didn't think that was a good idea at this time. Now, one thing I do want to point out, and I might point this out several times, when our students use computer algebra system, they use it for discovery, for checking homework. We never use CAS for assessments, because some people say, well, sure, they use CAS on their assessments, they're going to get them right. Well, no, that's not the case at all, so please don't even think that. All right, I should probably point out how I got involved with computer algebra systems. In 1999, many of you may know Burt Waits, who was one of the, we would call founders of the graphing calculator. He and Frank DeManna from the Ohio State University, started the graphing calculator movement back in the late 80s. And he asked me and Todd Edwards, who is now professor of mathematics at Miami University, to co-host or co-lead an international and national conference on CAS, and that's where I kind of got the idea about how to start using CAS. Got many good ideas from people all over the world and all over the United States. Jim Schulz from Ohio University was also a big contributor to the CAS movement. And the reason for that is that there are countries around the world that use CAS in their high schools and even require a CAS calculator on their final exams in high school. Austria has been using CAS for a long time with great success. And again, it's not using CAS to do the assessment, it's to do more difficult problems, to do higher level thinking. And you can find out about that at the conferences that there's a USA CAS conference coming up in Cleveland this summer where you can learn about that. This is the website for it, okay? This is bit.ly/CAS in Cleveland, basically. We'll talk about more of that a little bit later. But I've been involved with CAS for several years. Unfortunately, Dr. Burt Waits passed away this past year, and so our CAS conference is in his honor. He's also being honored by the National Council of Teachers of Mathematics at the conference in April this year for his lifetime achievement. So we're very happy and proud of Dr. Burt Waits. So what I'd like to do next is another activity that some of you, I'm sure, have seen this before, but for those you haven't, I think it's important that you do see it. How can you use a computer algebra system to assist students learning on how to solve linear equations? So I'm going to start with one like this. Solve 3x minus 5 equals 10x plus 12. And I can do this, I'm going to do it correctly, and then I'm going to show you how students can do it incorrectly, though I'm sure many of you teachers out there say, I've seen enough of those. I'd rather not see some more. But I want to show you how this helps students to learn that. So let me go on to back to the handheld version. And so here I have 3x minus 5 equals 10x plus 12. I had already typed it in just so that you didn't have to watch me do that. And so there are several things you could do here to solve this equation, and that's one of the reasons I like the CAS is that you have freedom to do things correctly, incorrectly, or even things that are helpful or that can be done but may not be helpful to solve the equation. For example, we could divide everything through by 3. That is a perfectly legal transformation. It really doesn't help us to solve this. In fact, it makes things worse because of the fractions, but it is a valid transformation. So for this one right here, I'm just going to go ahead and do what most students do, and that is they like to have the variable term on one side, and it must be on the left, or else they're really upset. So I'm going to go ahead and subtract 10x. So notice what I'm going to do is I'm going to touch the minus sign on here, and then 10, and then followed by the x. And notice what it says. It immediately said, well, you must be subtracting 10x from the last answer. And the last answer happens to be this equation, so I'm subtracting 10x from this equation. Now, it's programmed so that it means subtract 10x from both sides. Let me press enter and show you how it interprets it. So it doesn't show minus 10x on each side like I would like it, but it does say parentheses subtract 10x. And you'll notice that it subtracts 10x from the 3x and gets negative 7x. It still has the minus 5 on the left, equals, and then has just the 12 on the right side. So it does it correctly. This is the notation, and this is the correct answer. Now that we've done this, most students then would say, well, I need to get the variable term isolated, so I'm going to go ahead and add 5. So I'm going to press the plus sign, and immediately it's going to say, you want to add to the last answer, which is this equation, 5. And again, it means add 5 to both sides, but it's going to write it with this parentheses idea. And then it adds 5 to both sides. And now you can either multiply by negative 1/7, or I'm going to prefer to divide by negative 7 to make that coefficient of x a 1. And we come up with x equals negative 17/7. That was the correct way to do it. And eventually what we would have our students do in class is we might do it on CAS first to get the ideas so they can get a feel for the procedure. And then we would say, do this each step, one step at a time, do it by hand, then do it with CAS to check and see if each step you're in agreement with each step. Because this is doing two things really. It's showing you the procedure, but it's also checking the students' computation skills. I don't know how it is in the rest of the country, but in Northeast Ohio, we still have some students who do computation errors. Okay, if you don't have that problem, then this won't help you as much. But so it helps on both of those things because you got students who know the procedure but not the computation. You got kids who know the computation, not the procedure. It helps in both. Now, when we get to this part, with CAS especially, I want my students to check to make sure that this solution actually works. And I know if I ask my students, say, yeah, it works, and go on. But how I'd like them to do it is I'm going to have them go back and look at the left-hand side, which is 3x minus 5, and type that in or copy and paste it in. And say, I'd like to evaluate that with one of my favorite keys on the calculator, and it's located above the equal sign. I'm sorry, whoops. So it's control equal sign. And that's the such that key right there. And this says, evaluate the expression 3x minus 5 such that, and I'd like to evaluate it with x being this number. So I'm going to use a feature on Nspire, and that is click the up arrow and go up and grab that, say, I'd like to have that, and I'm going to press enter to paste it where the cursor was. And so this expression says, or this means to take the expression 3x minus 5 and evaluate it at negative 17/7. So when I press it, it will do that. And I get negative 86/7. I'm going to go to the other side of the equation, which was 10x plus 12, and type that in. And I'm going to evaluate that such that x is equal to negative 17/7. And again, so I don't type it wrong, I'm just going to go up and highlight that, which will now basically copy it and paste it when I press enter. And it's going to evaluate this expression at this number. And now I know that this is the value that makes the equation true because I get an identity, negative 86/7 equals negative 86/7. And when I have my students solve the equations, when they get to x equals negative 17/7, in order to show me that they checked, they must tell me what they got on each side to show me that they checked it correctly. Otherwise, again, this may only happen in Northeast Ohio, but some students will lie and say, yes, it checks when it actually doesn't. Now, I'm going to show you something that some teachers might have their students do, and I guess it's okay, but it's not for me, might go back up here and have you grab the equation and copy and paste it down, and then use such that key again, and say I'm going to evaluate this equation at -17/7 when x is -17/7. And it says it's true. And even though that's okay, I have students that will just say, oh, yeah, it's true. So, you know, the calculator is basically saying that. To me, this is much, much more valuable. Plus, this also helps the students understand what it is to solve an equation. Because a lot of times we think that they know what they're doing, and they don't. Sometimes they just think if I get the answer the teacher gets, then I solve the equation. They don't realize it's the number that makes the equation true. So this is a huge, huge help. It helps students understand the computations and the procedures. Now, we did it correctly. Now I want to show you what happens, because I think it's much more of a help to see what happens when they do something a little bit weird. So I got the same equation back in here, and I'll start off still by subtracting 10x from both sides. Oh, how did I do that? Oh, let me back up. Sorry about that. Let me copy and paste it. And now I get subtract 10x. I think it was forgot what I had done. There we go. So I subtracted 10x, got the same result as I did before. And now what I'll have some students that I know, they'll say, oh, I got to, quote, get rid of this 5 here, so I'm going to subtract the 5 to get rid of it. And so they're going to take this and subtract 5. And they get this, and they'll go, a couple things to that. One is, a lot of them will think it should have said -7x equals 7. And they'll go, what happened to this -10, okay? And some of them will come up to me and say, Mr. Riordan, you know, this calculator made a mistake. You know, I told it to get rid of the 5, and it didn't. And when I show it, they say, well, you subtracted 5, and -5 minus another 5 is a -10 or a -10. And they kind of hopefully would get that. Or the other half will say, oh, yeah, that's right. -5 minus 5 is -10. Oh, I goofed. Now, they have two options here. First of all, I would want to talk, this becomes a teaching moment. Is this an equivalent form to the equation we were solving? And that is this one. And the answer is yes. It was a valid transformation. It just wasn't a good idea. It didn't help us get this equation easier to solve. So they could either solve this one or they could solve this one. It doesn't matter. So I'm going to go ahead and just solve this one. And so now what I'm going to do is I'm going to add 10 to both sides. You can see the notation here that it added 10. And I'm sure you've had some students get this far and say, oh, well, I want to, quote, get rid of the -7, so I'm going to add +7 to get rid of the -7, because that's what we've been doing all along. And then we get to this, and again, some students say, ooh, did the calculator make a mistake? Did it not do this properly? And then say, oh, no, I really shouldn't have done that, because that's multiplied into undue multiplication. You have to divide and so on. So what the CAS does, it's like having teachers sitting next to you, and when you make a mistake, they're not as embarrassed, and they try to figure out what did I do wrong, whereas sometimes in the classroom, the teacher says, no, that's incorrect, they kind of take it personally, like, you don't like me, and that's why you told me it was incorrect, when in fact, no, it was just not good mathematics. So,
hey, Tom?
Yes, I'm sorry.
Sorry.
Go ahead.
No, I'm sorry to interrupt. Kara had a really good question. I was wondering if you could offer some thoughts on.
Sure.
Her question was, how does this transfer to looking on paper when students have the CAS taken away? So how do students, for instance, show their work on paper? Are they using the parentheses, et cetera?
Okay. Oh, no. Yeah, I show them by hand, and my way, I don't like that subtracting 10 underneath the equation, because technically that's not valid. I like to have everything on one equation. So what I would do on, say, something like this line right here, they would have 3x minus 5 minus 10x equals 10x plus 12 minus 10x. So we do it correctly on paper. And what I do have to tell them is, I don't want you writing this on paper. I want you to write it properly like we do. and they usually don't have a problem with that. And as far as once the CAS is taken away, they do much better because they were able to practice so many more times and get it right so many more times that they actually did much better. So this has not been an issue at all. And also the other thing is they don't like using the CAS because it's more time. But they get the idea that it helps them. They just would rather, well, you know, students, they would just prefer to get the problem done fast than get it done correctly. They would want to get it done fast, and wrong is okay. And so this helps them to be, you know, correct, and then when they don't have to use the CAS, they can actually work faster. So it's not been an issue at all. But very good question. Is that good?
Yep, I think that answered it well. Thanks, Tom.
I've seen there's been a lot of talking going along, and that's great. Okay, I haven't looked at it to see if it's positive or negative, so I hope it's good. But anyway, this is just one way, and you can see that if students make a mistake, it catches them, and again, they're not as embarrassed, and they learn from their mistakes instead of getting mad and maybe shutting down. So this, and I should tell you that I tried this with really low achieving algebra students, and the results were just amazing. So I have on my next slide, says, tell them the Harold McHugh and Debbie Burneye stories. And so real quickly, I want to tell you a little anecdote here. Harold McHugh was a student at our high school, a teacher at our high school for many years, taught Algebra 1, really not a fan of technology or graphing calculators. But when I showed him this with our TI-92s years ago, he used it, and every year would use that. He wouldn't use the grapher part. He wouldn't use anything else. But when we were teaching solving linear equations for a couple of weeks, he'd borrow the TI-92s and use the CAS because he saw it had great results for him, great results. And then Debbie Burneye is a math teacher at our middle school, and she was a former student of mine. And when she came to my graduate class this summer, saw the CAS, and so when she was ready to teach that to her 8th grade algebra students, said, can we go back over that again? And she tried that also with very good success in her classroom. So this is not just me talking. These are some teachers that aren't even into technology saying this works. All right, so let me make this a little bit bigger here. Jim Schulz, who I mentioned before, of Ohio University, who's now retired, asked me several years ago to develop a CAS unit for very low achieving Algebra 1 students. And it was at the end of the year, and it wasn't the topic I really wanted to do, but it was one of the ones I had to teach. And when I say low achieving Algebra 1 students, you might call them basic algebra, you might call them, you know, algebra half or something like that. But these were not the students that you know, wanted to be there at all. And so I decided to take on simplifying radicals with these very low achieving students. So let me go ahead and bring back the handheld and show you what I did there. And I think I have this on here. Yes, here we go. So this is another worksheet, a gift, if you will, of what I had my students do. Again, we hadn't talked about radicals at all, and so the first thing it says, number 1, type into your computer algebra system and write the answer, radical 2 plus radical 3. So they would type in the square root of 2 plus the square root of 3, and so on. And got this for an answer, wrote it down. And B says, is radical 2 plus radical 3 equal 5? And they didn't write just no. They wrote no, like it didn't say it was. So I attacked that problem right away, and they could see it would have said it if it was radical 5. And so we'll go ahead and do radical 4 plus radical 9. They'll type that in, see that the answer is 5, and say, is it radical 13? And again, the answer is no, because it would have said that if it did that, okay? And so then we went into these problems right here. And so I think I had already done this before we started. Yeah, here we go. 2 radical 3 and 5 radical 3 is 7 radical 3. They're writing it down. Remember, they don't have any prior knowledge of this at all. 2 radical 7, 4 radical 7. This one was a little bit funny. I heard the kids talking on 3 radical 5 plus radical 5 because they said, where'd the 4 come from? And I hear, 1 or 2 students say, I think there's like supposed to be a 1 in front of there, but we're like too tired or too lazy to put it in. So that kind of made sense. And this one, again, you see radical 12, radical 6, 6, radical 30. I mean, you see all kinds of weird answers here. But again, I'm going right after it, and I hear kids say, well, 1 of them plus 1 of them, okay, 2 of them, that's fine. And here again, you can't really add them. Now, it puts them in a different order only because this CAS has them go from larger to smaller. That's just the way the CAS does it. But I'm okay talking about the commutative property. So we also would say it's the same as radical 3 plus radical 5. So once they've done this, it says to look at your input and output, very similar to what I did with the exponents a few minutes ago. Based on your observations, discuss in your groups, when can you add them, when can't you add them, and write some generalizations here. And that's very hard for them. They aren't really wild about doing that. But I do want them to get something down there and really get some discussion going. That's really the important part. So then we go into the same exact thing except with subtraction. And so they'll find out, no, it's not radical 2, no, it's not radical 5, and they, again, see that you basically subtract the coefficients as long as you have the same radicand, though I don't hear that word radicand, but I would love to hear it someday. And then have them discuss it. When can you subtract them? When can't you subtract them? And so on. And then we move on to multiplying. And so they'll multiply radical 2 times radical 3, get radical 6, and so on. And I can hear the kids saying, now these are the types of rules I like. If I were making up rules, these are the rules that I want to run to see, okay? And even division, kids who don't like division say, you know what, radical 6 divided by radical 2, radical 3, I can get into that. That's fine. And so they'll talk about that. It says sometimes you can add or subtract, sometimes you can't, sometimes you can multiply, divide, sometimes you can't. Discuss those, and it is hard to get them to discuss it, but, keep working at that. And so finally, we get to what I would call the homework, the opportunities to learn. And it says for each of the following, simplify, if possible, without using CAS, simplify if possible without using CAS, write your answer, then do it immediately with the CAS, smile if you're right, X if you're wrong. And again, if they miss this one, radical 5 plus radical 6, and then told they were right, then when they get to number 22, which is a similar type problem, I'm hoping the chances are better that they won't get it wrong again. But if they just did it like they traditionally did homework and miss this one, they're going to miss this one, they're going to miss this one, and they're going to just reinforce bad stuff. And it's harder to unteach and reteach rather than just to teach right, get it right the first time. So they go through, and this is their assignment, and that's day 1. Now, what I'd like you to realize is with the lowest achieving Algebra 1 students that I have in our building, I just taught them on the first day, add, subtract, multiply, and divide radicals. Not really hard ones, but did that. And I've not ever done that with honors algebra students. Now, day 2, I don't have all the days here, but we started off while I'm checking their homework. Try this without a CAS, try with a CAS, smile or wrong. Okay, just an example of each type. And then we get to exploration of what happens when you square a radical. And with CAS, without CAS. What happens if you have coefficients in front of the radicals? What happens? This is a very prominent one in a geometry class, squaring 3 radical 5, and you get 3 radical 5 and 9 radical 5 and all kinds of weird answers there. So I'm addressing those right away. Again, more practice, reinforce self-assessment. Kids like the self-assessment. Squaring these things, how that goes. That could be a mess. Okay. Questions come up. Do the kids have CAS at home? For this project, yes, they did. I had borrowed the calculators from Jim Schulz, so they did take them home. That's the better way to do it so that they can do these things at home. But if you can only have them in class, you'll just have to work your assignments around it. All right, so then this is the self-check. Again, this is the homework, and notice I threw in addition and all these other ones and so on. So this was day 2. Now, I don't go through the rest of it, but you kind of get the idea. And I come to the point where how did CAS assist my students to learn better? So what I did was I came up with a quiz after several days, and I look at this, it's very traditional. I'm almost embarrassed that it's so traditional, but this is what I gave them, 20 problems. Keep in mind, they were not allowed to use CAS for any assessment that counted for any kind of grade, okay? Self-assessment, yes, but not for summative assessments. So this is a problem, and before I give you the results, I want you to again remind you of these students, okay? Whoops, didn't mean to give that to you right away. Traditionally, most get D's and F's. Those kids' goal in life is to get a D minus. 2 D's, 2 F's in the 4 grade periods and just barely pass, because that means they've done the least amount of work and still passed. So normally I got mostly D's and F's, a few C's, rare B's and A's, okay? These were the results on that. Now, it was a small class. Our lower achieving classes usually are smaller. They're usually between 15 and 20. And this was amazing. I did not have anybody fail, and instead of being bottom heavy, it was extremely top heavy. And I was excited and happy, and then I was mad. It's like, where have you guys been? How come have you been holding back? And I just believe that the CAS helped them. It gave them confidence. It told them when they were wrong and helped them to figure them out. And it just went from there. Now, I did the same thing with another thing. Hopefully we'll have some time later to show you how I work with rational expressions. But before we do that, I'd like to look at the computer algebra system menu on the TI-Nspire CAS handheld. If you have other CASs, you can do this also, but I want you to see how you can, just all the power that's available there. And it's very similar to the 8992, and we're going to look at the algebra and calculus menus. Even if you don't teach either one of those, one or the other, still be aware of what's there. And what I'm going to do is I'm going to now switch over to the iPad because I want you to be aware that this can be used on the iPad app. There's an iPad app that is $30. I'm sorry, no, it's $29.99. They told me it's not $30, okay? And you can get a CAS or non-CAS version, and if I were a teacher, I would get the CAS version just for a lot of reasons, and hopefully you'll see why today. So let me see if I can pull up my iPad, and perfect. The iPad is there. So I'm going to open up TI-Nspire CAS iPad app, and this is a file that I created earlier today. And if you're wondering which iPad one you have, the CAS is in a blue icon and the non-CAS is a red icon, okay? And by the way, at the website that I created, there's links to the iPad app and many other things that I'll talk about towards the end. So, all right, so this is the CAS one. I'm going to tap on the tools. Hopefully you can see an orange circle when I tap on something. And let's look at the algebra menu. Now you'll notice here I've got solve, factor, expand, find the zeros, complete the square, solve systems of equations. We even have trig, complex, all kinds of things here, okay? So first of all, let me go ahead and expand. And this keyboard that pops up is not an Apple keyboard. It's kind of a equation editor or a math type thing, and it's wonderful. It has everything you could possibly want. So I'm going to expand the quantity of, let's say, x plus 2, the quantity raised to the 5th power. And because it's a CAS, it will do it immediately. I'll go back to the algebra menu, and let's look at factor. So how about factor x squared minus x minus 6, a simple one. You can see it factors nicely. You could actually type in the command if you want, factor. but our students, unfortunately, factor is ER, so that won't work. But now here are my favorite arrows, or favorite keys are these arrows right here. So what I can do is go up and say I want to copy that, so I'm going to press return, and it'll paste it right in the factor. Press enter, and this is really what CAS is designed, is to factor things that are not obvious right away. You can solve all types of equations. Let's go with maybe x squared minus x equals 6, and I want to say comma x, meaning solve that equation for x. Love the word or there. You can also solve literal equations. So I'm going to solve, and notice I don't have a y here, so I'm going to tap on the x, and since it has a bar, I have these other variables available to me. So y equals, I don't think there's an m on here, so I'm going to need an m for the m for slope, times x plus, and then b is above the a, if I remember correctly. And I'm going to solve that, comma, for x. And you can see it'll solve literal equations. That's a simple one it'll do, kind of nasty ones also. Another thing it'll do is if I want to talk about, say, radical 24, this isn't going to give me 4.9 something. It's actually going to simplify it to 2 radical 6. So that's the algebra, some of the things on the algebra menu. Since I knew we didn't have a whole lot of time, I did some other ones. Here's solving basically the quadratic formula. It's a little bit different form, but to me that just brings up a good conversation about equivalent forms. And that's something you talk about a lot when you use a computer algebra system. Here I solved a system of 3 variables, 3 equations, 3 variables. Not nice answers. In fact, I would probably have my students show that they checked. And then adding 2 rational expressions, and just said find the common denominator, combines them into one single fraction. For calculus, real quickly on calculus, these are all the things you can do algebraically in terms of variables, not in terms of numbers. And so if I want to take the derivative, let's say with respect to x of x to the 5th power, it'll do that. Again, some of the other ones you can do, I did them on here. Here you can find an antiderivative. Sorry, there's no plus c here, but I guess that's where we come in. There's got to be something we can do. Finding definite integrals, finding limits, both right-handed, left-handed limits, and straight on. Summation, and this one really got me. I never expected this. The sum of the perfect squares, I from 1 to n. This is such a familiar formula to all of us, and even the CAS knows that one. But this is just a small part of what it will do, okay? A small part of what the CAS will do. All right, so what do I have next? Dynamic algebra. One of the people, one person asked me, so how would you explain CAS to somebody? And I said, it's kind of like dynamic geometry, where you can investigate things and pull things around and see them change and interact with it. And so she said, you're talking about dynamic algebra. And I said, yeah, you know, that's a good phrase for it. So I attended a CAS conference that Neville Hopley of Scotland did, and he taught me several new cool things. One of them was how he gives students a little bit nastier looking equations to solve and says, do them with the CAS and keep doing things until you solve it. And then you're going to make mistakes and find out what worked, what didn't work, and then go back and try it again, and then finally write it up by hand. And eventually tries to wean them away from using the CAS by giving them these types of equations and have them solve them again by hand, okay? So for this one right here, let's go ahead and solve this equation here. And I'm going to start off by doing some things that some students would do but really aren't going to help. For example, a lot of them say, oh, there's the x on the right-hand side. What I think I'm going to do is, let me go up there and restart this. I think I'm going to subtract 1 from both sides. There, and I've solved for x. You can see right there I've solved for x. And of course, it's x solved for x. That's really not solved yet, so that really didn't help us. Keep in mind, though, we would talk about this as still an equivalent form to the original equation. It's just not finished solved. So another thing they might do is, well, how about if we add 5 to both sides? And, well, you know, that oops, I didn't do it, did I? Add 5 to both sides. And all that did was give me another equivalent form, okay? So eventually, hoping we're thinking, well, how about if I multiply everything through by x? And so we get something like this. And so what you would like to do is maybe expand that. So I'm going to go back to the tools, and under Algebra, expand is one of my tools. Notice where the cursor is blinking. I'd like to expand that equation above it, so I'm going to use my up arrow to select that and then press Enter to copy and paste it in there. So I'm saying expand that, meaning expand anything on both sides. Press Enter. And now I've got this equation, so what I can do is subtract 6 from both sides, and then I can go ahead and factor it or solve it by the quadratic formula, but let's go ahead and do it by how we would normally do, and that is factor, go up and grab it, and hopefully from this one you could do it by inspection, x equals 1 or x equals -6. And then going back up to the top here, let's just go ahead and we can just go ahead and try and see if x is 6, we get, if x is negative, what were the two answers? I forgot already, sorry. 1 and -6. So -6, we get -1 minus 4 is -5, -6 plus 1 is -5. Okay, that checks. And then when x is 1, we get 6 minus 4, which is 2. The other side, 1 plus 1, which is 2, so that checks. So here's a case where you give students an equation and say, you can't stop. You have this tool that will help you do whatever you want to do, keep trying things, and what it does is it teaches them to persevere, because a lot of students, you know what they'll do, they'll hit this equation right here, they'll try one thing, it didn't work, and say, show me, I didn't get it. And what we want is we want that perseverance. That's one of our math practices that we're hoping to get our students to be able to do. Neville talked about a problem that he gave students that I thought was really kind of cool. It was, I think, something like x minus r over x plus r, x plus r equals, let's say, a, and solve that for a, or solve that for x. And he said he showed part of a 5-minute video where the girl did some like 34 steps before she finally, I don't want to say stumbled upon the answer because she got it, but she stuck with it, she persevered, and then he said, I want you to go back and now try to do it with fewer steps with the CAS and then try to do it by hand. But this is the type of problem you can now give students and say, you've got a helper there. Keep using that and then try to wean yourself away. So Neville is one of the people that is going to be one of the CAS expert speakers that we're going to have at the International Conference in July in Cleveland. I am helping to organize that, so yes, I am plugging it. But if you're interested in learning about CAS and finding out about it, these are the types of things you'll see, and you're going to see from people much, much more knowledgeable and clever and expert than I am. Some of the people we're going to be having, we have people from Australia, Canada, Austria, Scotland, a lot of the universities, just many, many, many more, okay? And for those people who aren't on this list, I apologize, but I couldn't fit you all in. But we have, I don't know, 30 or 40 speakers going to be there in Cleveland. This, again, is the website. All lowercase, bit.ly/CAS in Cleveland. And with that, I had some other things I was going to tell you, but I know Mike wanted me to allow some time for questions, and I saw there was a lot of going on. So, Mike, if we have some questions, that's great. If not, I can probably tell him a couple other things. But we got questions?
I think I've done a pretty good job about answering most of the questions that have popped up. But again, if you have any last-minute questions for Tom, feel free to ask that in the chat window. But Tom, if you want to show us something else, that'd be great.
Okay, I think what I'll do is just kind of tell you other things I've used it for, and I won't illustrate them because we have the time, and I know you want to close this up also. But one of the things I showed my students was how to investigate rational expressions. So I'd have them type in 3x over 3y, and it would simplify to x over y. And then I'd have 3 plus x over 3 plus y, and it wouldn't simplify. And, a lot of students would cross out the common 3's and say, divide it out and so on, so I addressed that right away. Teaching them function notation, like finding f of x plus h, also using function notation to create things like, what does a hamburger or a milkshake and a french fries cost? What if it's 3 milkshakes, 4 french fries, and 2 hamburgers, and they create a function in 3 variables with CAS and evaluate it. Odd and even functions, verifying trig identities, it's geometric discoveries, and then using CAS to help verify or prove them. These are all topics that I've used in CAS talks and others that people have used. So, it's something to consider. I realize people say, oh, they can't use CAS on our exams, so we're not going to use it. What I have to tell you is they can't use teachers on their exams, and they still use you to learn. They are not use books on their exams, but they still use books to learn. You can use CAS, you can use graphing calculators to help students to learn. You can use dynamic geometry to help students learn. But just don't let them use it on the assessments, okay? But it definitely is a helping teaching tool and a learning tool. So with that, I'll turn it back over to you, and hopefully there's somebody still there.
Thanks, Tom. And I just want to piggyback on that and at least mention how I started using CAS in my classroom. Whenever we decided to start using TI-Nspire technology, all of my students were using TI-84 technology, which is still a really, really great and viable technology. But I decided that we were going to make a switch to TI-Nspire. And whenever I did that, I definitely saw some powerful potential with CAS. We didn't have the ability to get all of our students TI-Nspire CAS technology. So I started by just using the teacher software, the TI-Nspire CAS teacher software, which Tom was using tonight. And I would do a lot of what Tom was doing, a lot of the demonstration pieces. But instead of having my students type it in individually, I would do it up front. I would ask them what they expect to get. And so it wasn't the same interaction, but at least my students were being able to try something, ask questions, and to see why did we get a certain answer. It really provides some really great talking points, even though my students didn't have TI-Nspire CAS technology at their fingertips. So I just want to at least interject with that.
I'm glad you said that, because even though you only had one computer algebra system available to you, it's funny how if you have done the problem, got the answer, when the CAS does it and gets the answer, it's like they trust it more than us, which I used to get upset about, but I've gotten over that. They trust that black box, and if that's going to help them learn, I'm okay with it. So yeah, I think that's a great way to use CAS if your students don't have them.
Thanks, Tom. So a couple last-minute things. We do have some upcoming webinars, which you can register for. They're all free. Registration is open for the rest of the spring series here, and those are available on our website. We were using Twitter tonight to start and hopefully continue a conversation. So please feel free to check us out on any of the major social media outlets and continue the conversation from tonight. To receive a certificate of attendance, go ahead and click that link in the chat window. It contains the name, date, and duration of tonight's event. Also included there is a link for the documents. That was the link that Tom had mentioned earlier, and I know there's lots of really, really good stuff that he put in that documents link. So not just specific things about this webinar, but also more global things like registering for the international conference, for the International CAS conference in July, or the international conference in Fort Worth, Texas, coming up here in a couple weeks. So please feel free to check out those two links. If you happen to miss them, no worry, you'll automatically get an email in a couple days that will automatically give you a link to the recording, a link to the certificate, and a link to those documents. If you're looking for some post-webinar follow-up or you have some additional questions, please feel free to jot down one of those two email addresses and follow up. So Tom, I already saw a lot of people giving you thanks. I want to do the same thing. I know you put some work into preparing for tonight. I really appreciate all of that. I learned a couple things, and that's always a good thing. So Tom, thank you so much for everything you did tonight.
Oh, no, my pleasure. If anybody has questions, you've got my email address. Be glad to answer them. And thanks for having me.
Really hope to see everyone back online next week. Thanks so much.